Hello friends. Okay, in the previous two videos we already learned what is a logical statement and what are logical connectives, their truth tables and few examples also. Now let's see few more basic definitions such as statement pattern, statement letters and logical equivalence, and so on. Okay, so without wasting time, let's get started. Statement pattern. Okay, so before knowing the definition of statement pattern, we are supposed to know one thing, that is statement letters. Statement letters means those letters that we use to name a statement or that we use to denote a statement. Okay, suppose P or small letter Q, all these small letters we use to denote a statement or to name a statement, and those small letters are called as statement letters. Okay, now a combination of statement letters and connectives are called statement pattern. Okay, combination of statement letters and connectives are called statement pattern. So for example, P and Q is a statement pattern. P biconditional Q is a statement pattern. Alright, so now let's see the next topic. Logical equivalence. When there are two statement patterns having identical truth tables, then they are said to be logically equivalent. Okay, so there are two. If you take two different statement patterns means what? Combination of statement letters and symbols, connectives is called statement patterns. Okay, and now if you take two different statement patterns and if you make the truth table of them, and if they are equal, then identical, if the truth tables or the outcomes are identical, then we can say that those two statement patterns are logically equivalent. Now these things you will understand more when we will discuss the examples. For now, just think that if there are two statement patterns and if you make the truth table, and if the truth table match of both the patterns, if they match, then they are logically equivalent. Okay, now if a statement pattern A and B, both there are two statement patterns, suppose if they are equivalent, we will write it as A equivalent B. Alright, this will be the symbol used for equivalence. Okay, fine. Okay, so now let's see how we can categorize the statement patterns as three types. Okay, so before that, the statements in a statement pattern are called prime components. Okay, statement pattern is a combination of statement letters and connectives, and the statements which are part of this statement pattern are called prime components. Okay, because the truth values of them will affect the truth value of a statement pattern. Okay, so now let's see what are the three types of statement patterns. Now these types are derived depending on the truth values of the statement patterns. Okay, so there are three types. The first is tautology. That means in all cases, if the statement pattern is true, then we call it as a tautology. Next, if in all cases the truth value of that statement pattern is false, then it is called as a contradiction. And if it is not a tautology or a contradiction, then we come to the third, that is contingency. Contingency means the truth values of that statement pattern will be a combination of truth and true and false values. For some cases it will be true and for some it will be false. Okay, it will be a mixture of both. Then this contingency. Okay, now let's see the detailed definition of three. Tautology. A statement pattern whose truth value is true for all possible combinations of truth values of its prime components is called tautology. Now we denote it by T. Okay, a statement pattern whose truth value is true for all possible combinations of truth values of its prime components. That means a statement pattern has its prime components and logical connectives. Okay, so for different combinations of truth values of the prime components or the statements, the truth value of statement pattern will be different. Alright, and if in all possible cases they are true, then we call it as a tautology and we denote it by T. contradiction. Okay, so let's see the definition. Before that, let me take the laser. A statement pattern whose truth value is false for all possible combinations of truth values of its prime components is called contradiction. Okay, this we already discussed before. So now here it is something similar. Truth value is false for all possible combinations. That means what? What are the prime components of a statement pattern? Obviously the statements in it, right? And we will form different combinations of it when both the statements are true, when one is true, one is false, and when both are false. In all cases, if the outcome is false, then we call it that statement pattern as a contradiction, and we will denote it using small letter C. Okay, now let's see the third type. Contingency. Contingency means a statement pattern which is neither a tautology nor a contradiction is called a contingency. That means in the truth table of such a statement pattern, we will find both the values. In some cases or in some combinations it will be true, in some combinations it will be false. It will be a mixture of both. Okay, then we can call that type as a contingency. Okay, now let's see some basic truth table of the different logical connectives, which we already discussed in the previous video. It's just like a summary. Okay, so this table is really important. Now here they are showing statement P, statement Q, negation of P, P and Q, P or Q, P implication Q, P double implication Q. Okay, so in this how we have four different cases. First case is when both the statements are true. Second is one is true, other is false. Third is first one is false, second one is true. And the fourth case is both the statements are false. Okay, now let's see how is negation P. When P is true, obviously negation P is false. Again here also P is true, so negation P is false. And when P is false, the negation of P will be true. Okay, let's see P and Q. In P and Q, only when both are true, we have already seen that when both the statements are true, P and Q is true. So in one case it is true, and in rest three cases it is false. Okay, because one of the statement is false. Now here in P or Q, only once it is false, when both the statements are false. In all other three cases it will be true. Okay, here in implication we know that when T goes to F, that is when the first statement is true and the second statement is false, only that time we have the implication to be false. In all rest three cases the implication is true. And in P double implication Q, when both the statements have same truth values, then it is true, and in other two cases it is false. So now here when both the statements have same truth value, that is true, the double implication is true. And when both the statements have same, that is false, the double implication is true. And the rest two cases the double implication is false. Okay, now this table we have already seen individually when we learned the logical connectives. This is just like a we can say recalling. Okay, now let's see, in a statement pattern different symbols are considered in the following priority. Now if you see, negation is first, then or, then and, then comes the implication, and the last is the double implication. Now the importance of this hierarchy or this priority we'll understand when we discuss the examples of different examples of statement patterns, and that I will discuss in the next video. Okay, thank you. Okay, thank you for listening to my video. If you liked the video, please like it and share it with your friends, and subscribe the Frenta channel. And as I said, in the next video I'll be discussing about the examples of statement patterns. Okay, bye.